Get some more exponential functions. 1 second. Yeah, let's go. So let's say we have an equation given like this: e power x is equal to 7. How can we solve this? And whenever there's an e in the given problem, and if they ask you to solve for x, it's always good idea to get ln. And what happens is, here the exponential we can move to the front, so this is x ln of e, that's equal to 7, and ln e is 1, so the x times 1 is equal to 7, therefore x is equal to 7. Now let's look at another example. Also, if you want to verify this one, you can plug this value, x value for wait a minute, I have to make sure I'm trying. Okay, you know what, I made a mistake here. If I'm taking ln this side, I have to do it both sides. So this is wrong, I have to do it again. So if it's ln e power x, then this is ln 7. Therefore x is going to be equal to ln 7. And you can plug this ln value in calculator and find the x value. If you plug it in the calculator, you're going to get 1.9459. And that's our x value. Now let's look at another question. Let's say we have a question given like 5 plus 4x minus 2 is equal to 23. Here we want to solve for x. Now whenever we have number, the best practice is to make them simple first. So I can keep the power function as it is, exponential function as it is, 4 power x minus 2, and then that's equal to 23. And then here we have plus 5. If we move to the other side of the equation, that's minus 5. So this is 4 power x minus 2 is equal to 23 minus 5, that is 18. Now we have to see whether we can bring these two sides in the same base. Like for example, let's say if you have same base like 2 power something and 2 power something, then we can equate the powers. But here if you look at this is 2 power 2 is 4, but 18 is not 2 power. 2 power 4 is 16, but 18 we don't have anything. And if you take 3 power nothing here, and here also nothing. So the power, we cannot take the same base. We don't have any situation that will provide the same base. So when you have a situation like that, you can take log both sides. So here we can take log both sides. Log 4 power x minus 2, that's equal to 18. I mean, we have to do log both sides. So this log 18. Therefore, and also you can move this x minus 2 to the front. So this is going to be x minus 2 in the parenthesis, log 4. That's equal to log 18. Now we can solve for x minus 2. That's going to be log 18 over log 4. And if you also we can move this 2 to the other side. That's going to become, okay, I continue here. You know what, I can just erase this thing and write it on top. Okay, the continuousness right here. Okay, so the x, I'm going to equate that one to log 18 over, this one is log 4 plus 2. Now if you calculate this value in calculator, you're going to get 2 remains the same, and this value is 2.08496. Now we can go ahead and add them. If we add, we're going to get 4.08496, and that's our x value. Now let's look at another problem. Let's go ahead and erase the whole thing. Let's say we have a question like this. 3 plus 2 e power 3 minus x, that's equal to 7. Now the first one is, let's simplify the constant values. So 2 e power 3 minus x, and then here we're going to have 7 minus 3. Therefore 2 e power 3 minus x is equal to 4. Now whenever we have e, it's best practice, it's a good practice to take ln, but here we have 2. Let's get rid of that one first. E power 3 minus x, and if I bring 2 to the other side, that's going to be dividing 4 by 2. So e power 3 minus x is equal to 2. Now whenever we have e, it's best practice to take ln both sides. So if I take ln, this ln e power 3 minus x, and the other side we are going to have ln 2, and this 3 minus x we can bring to the front. So 3 minus x ln is equal ln e is equal to ln 2, and ln e is basically 1, so we can just put 1 for this. So if we go and simplify, so this is 3 minus x equal to ln 2. Therefore we want to solve for the x, so 3 minus ln 2 is going to be x. And if you calculate this value using calculator, you're going to get x value to be approximately 2.3069. Okay, now let's look at another problem. Let's go ahead and erase this one. So let's say we have a question like this. We have a question that's given like 3 power x plus x square plus 4x, and in the other side of equation 1 over 27. Now here we can see we have 3, and also in the other side we have 27, but this is 1 over 27, and we know that 3 cube is 27, because if we can take 3 cube, we have the same base, so we can solve for this. But here we have 1 over 27. If you write 1 over 3 cube, that's basically 3 power minus 3. 3 power minus 3 is 1 over 27. So we can put that here. So if you do that, this is going to be 3 power x square plus 4x, and this is 3 power minus 3. So if we have the same base, the powers are equal, so we can just equate them. X square plus 4x is equal to minus 3. Now it seems like I can factor this by bringing all to one side. X square plus 4x plus 3 is equal to 0. Now here we have to look for a value that when we multiply we get 3, when we add we get 4. So if you look at that, we have to get 3. So 3 times 1 is 3, and if you add 3 and 1, you're going to get 4. So we can say x plus 3 and x plus 1 is equal to 0. Therefore x is equal to negative 3, and also x is equal to negative 1. X has 2 values, and that's the answer for this question. I hope you guys find this video helpful. Thanks for watching. See you guys on my next video.